Okay, today we're going to learn about graphing from vertex form, which is section 6, topics 4 through 6 in Math Nation. So what is vertex form? Vertex form looks like this. F of x equals a times x minus h squared plus k. The a in vertex form determines if the function is positive, meaning the parabola opens up, or negative, meaning the parabola opens down. So just like when we had our function in standard form, it's the same in vertex form. If there is an a term, it determines if the function is positive or negative, and if that parabola opens up or down. The h here is the axis of symmetry. Which is the x value. So remember, our h here is our axis of symmetry, which is the x value. And I want you to pay close attention here because I highlighted just the h. It is not the negative. This negative is meaning it's the opposite. So if we have a negative h, then our axis of symmetry, or our x value, is positive. And if we have a positive h, then that means that our x value is negative. We'll get some more practice with that coming up soon. Okay, but that negative is really going to affect what happens. Okay, we'll deal with that here in a moment. K. So K, when we're in vertex form, K is the y value of the vertex. And I'm going to highlight that in orange because I've always been highlighting the vertex in orange. So K is the y value of our vertex. So when we're given a function in vertex form, the point HK is the vertex of the graph. The coefficient A determines the width and if the graph opens up or down. If the absolute value of A is greater than 1, the function is vertically stretched. Example, so if A was 2, or if A is negative 2, because the absolute value of both terms would be equal to 2, which is greater than 1, then that parabola is going to be stretched out. Now, if the absolute value of A is less than 1, the function is vertically compressed. So an example of that would be if A was equal to 1/2, or if A was equal to a negative 1/2. Now stretched, and I'll try to give you an example here, is a really skinny parabola, okay? And a compressed parabola is going to be one that looks a little bit more like that, where it's a little bit more flattened out. Let me erase that and give you a better example. Okay, so a compressed parabola is when my A term, is less than 1, and I have a wider parabola. And a stretched parabola is when my A term is greater than 1, and when I have kind of a skinnier, so you think about a stretched out parabola, a skinnier parabola. Okay, so the following steps to graph from vertex form. So we have f of x equals x minus 3 squared minus 4. So step 1, identify the terms a, h, and k. So a here is equal to 1, h is equal to 3. Notice I did not include that negative, okay, because we're ignoring that negative when we're talking about vertex form. And k is equal to a negative 4. Step 2, determine if the parabola opens up or down. Well, my a term is 1, which is positive, so my parabola is going to open up. Step 3, identify your vertex and axis of symmetry, h of k and x equals. So my vertex is going to be 3, negative 4, and my axis of symmetry is x is equal to 3, because that x term here in my vertex is my axis of symmetry. So we had step 1, which was identifying all key 3 parts of our vertex form. Step 2, we determined if that parabola was opening up or down. Step 3, we identified the vertex and the axis of symmetry. And now we're on to step 4, which is find your y-intercept by plugging in 0 for x. So we're going to find f of 0, and that's going to be equal to 0 minus 3 squared minus 4. Okay, negative 3 squared is equal to 9 minus 4 is equal to 5. So my y-intercept is equal to 0, 5, because my y-intercept is always when my x is equal to 0. Now step 5, find the x-intercepts by solving by square roots and plugging in 0 for f of x. Okay, so what do we mean by step 5? So for step 5, and I'm going to add a note here, is that if you can't solve by square roots because you have a negative number, you can still use a table of x and y values to solve, okay? So step 5, we're going to take this function, f of x, and we're going to write that now with a 0. So 0 equals x minus 3 squared minus 4. And now we're going to solve this function. Well, to solve this function, I'm going to move this negative 4. I need to move that over here. So in order to do that, I'm going to add 4 to both sides. And I get 4 is equal to x minus 3 squared. And then I'm going to take the square root of both sides. Okay, because I have a squared binomial and I have a whole number on the other side, I can just take the square roots to solve. So the square root of 4 is plus or minus 2, and that is equal to x minus 3. Well, I'm almost there. Now I just have to solve x minus 3 is equal to a positive 2. I add 3 to both sides, and I find x is equal to 5. When I do x minus 3 and set that equal to a negative 2, I then add 3 to both sides, and x is equal to 1. Now I have my two solutions, my x-intercepts, and now that I have all of the points, I can graph it on my coordinate plane. All right. So my vertex is at 3, negative 4. My y-intercept is at 0, 5. And my x-intercepts are at 5, x is equal to 5, and x is equal to 1. And I can use my fifth point, I can just reflect it over the axis of symmetry, which I'll put in right now. So if I reflect that y-intercept over the axis of symmetry, I'm going to be right here. And there I have my parabola, or this function, from vertex form. All right. Now let's look at example number 2. Okay, we have f of x is equal to a negative x plus 3 squared plus 4. We're going to do our first step, and we're going to identify our a term, which is a negative 1, our h term, which is going to be a negative 3 now, because this is positive, and I remember it's going to be the opposite. Oops. Sign for my h. Okay. Don't forget it's the opposite. So my a is equal to negative 1, my h is equal to negative 3, and my k is equal to 4. So step 2, I'm just going to determine if my parabola is going to open up or down. And since my a term is negative, it's going to open down. My step 3 is identify the vertex and axis of symmetry. So my vertex will be negative 3, 4. My axis of symmetry is going to be x equals negative 3. Okay, so we have 1, 2, and step 3 done. Step 4, we're going to find our y-intercept. I think I did step 4 in green. Yep. Step 4, we're going to do our y-intercept. So in order to find our y-intercept, we're going to plug in that 0 for our x. So f of 0 is equal to a negative x plus 3 0 plus 3 squared plus 4. Well, 3 squared is 9 plus 4. What did I forget? It's not plus 9, it's a negative 9 because I have a negative in front. So let me show you what that looks like and why. So we have a negative multiplied by that 9 because that 3 squared is 9 plus 4, which is equal to negative 9 plus 4, which is equal to a negative 5. So my vertex, my y-intercept is equal to 0, negative 5. And my y-intercept should always be listed as an ordered pair. All right, now we're on to step 5, which is to plug in that 0 for our f of x. So 0 is equal to a negative x plus 3 squared plus 4. Well, now I just need to solve. And because I have a negative in front of that binomial, I'm going to add that binomial to the other side instead of subtracting that 4. So I can add x plus 3 squared to both sides. And then I get x plus 3 squared is equal to a positive 4. Now I can take the square root of both sides, and I will get x plus 3 is equal to plus or minus 2, because the square root of 4 is 2, and then I can split that and solve. So x plus 3 is equal to a positive 2, and x plus 3 is equal to a negative 2. If I subtract 3 from both sides, x is equal to a negative 1. There's 1 x-intercept. And over here, I need to subtract 3 from both sides. And I get x is equal to a negative 5. And those are the two solutions for this function. Now I just need to graph my points. So my vertex is at negative 3, 4. My y-intercept is at 0, negative 5. And my solutions are at negative 1 and negative 5. And because of the reflection point of my axis of symmetry, I know that my fifth point will be at negative 6, negative 5. So I'll go ahead and highlight those values so you know where they came from and connect the dots. All right, that is the notes portion of the classwork for Monday, March 22nd. I am going to go ahead and do this first practice problem with you in this video because I want to show you what happens if you cannot solve by the square root method. So in this practice problem, we have f of x equals negative x plus 4 squared minus 2. So we're going to do just like what we did before. Step 1 is we're going to identify our a term, which is negative 1, h, which is going to be equal to a negative 4, because this is positive, so my 4 is going to be the opposite. And then k is equal to a negative 2. Step 2, I'm going to determine if that parabola is going to open up or down. And since a is negative, it's going to open down. My step 3 is to identify the vertex, which is going to be negative 4 -2. And my axis of symmetry is going to be x equals -4. All right, at this point, if I go ahead and graph my quadratic function, just the vertex, I'm at -4, -2, and I put my point. I know because of step 2, my function is going to open down. So at that point, I should realize that I'm not going to have any solutions. So my step 5 is going to look a little different. Let's first find our y-intercept. So I'm going to find f of 0, and that's going to be equal to a -0 plus 4 squared minus 2. Well, that's going to be a negative times 16, and that's going to be -2. So -16 minus 2 is going to equal to a -18. All right. That's going to give me a problem as well, because when my y-intercept, that's what I should be writing here, my y-intercept is equal to 0, -18. And if I look at this graph, my y-axis does not go all the way down to 18. So step 5. We're going to use a table this time instead of solving by square roots. And we can always use a table to graph. I told you that 2 weeks ago before spring break. We can always use a table to graph. And we're going to use our axis of symmetry, our vertex, to help determine the values in our table. Okay, so remember we have our x values and our y values. And because our x value is going to be our parabola is going to be centered on -4, that's what we're going to put in our graph first, in our table first. So from -4, I can do -3 and -2. And I can list -5 and -6. Okay, so now I'm going to find f of -2, and that's going to be equal to a -2 plus 4 squared minus 2. Well, a -2 plus 4 is going to be 2. 2 squared is 4, so I'm going to have a -4 minus 2, which is equal to a -6. So when my x is -2, my y is -6. Now I'm going to find f of -3. That's going to be a -3 plus 4 squared minus 2. Well, a -3 plus 4 is just 1. 1 squared is 1. So I'm going to have -1 minus 2, which is equal to a -3. That's my next point, and I'll highlight that in a different color on this graph. I already know the y value of -4, it's -2. And I know that this is my vertex, and I know that my points reflect on the opposite side of my vertex. So if I have a -3 here, I know that I'm going to have the point -5, -3 down here as well. And the same thing's going to happen with that -6 and -6. So now I can go ahead and graph these points. -2, -6, right here, and -3, -3, right here. My vertex is already graphed. -5, -3, right here, the reflection point, and -6, -6, right here. And there I have my parabola, or this function, and I was able to use a table of values in order to graph my function, because you can always use a table of values to graph any type of function. All right, go ahead and do practice problems number 2 and 3 on your own. You can ask me for help in class if you need it.